Hello everyone. In a previous video I was asked if I could do an Arduino project. So today I will create a new project using my Arduino board. In this case I have an Arduino Uno and I would like to show how to bring it up and let's build something out of it. So to get started, the first thing I do, I go to Awesome Embedded Rust because this has a list of curated crates that are and hardware abstraction layer for embedded Rust specifically. And I would like to find out how I can bring an Arduino up. If I go through the list, peripheral access crates require unsafe, so this is just a basic layer of access. So what I'm interested is in implementation crates. AVR and Arduino are microchip, so I could go to microchip and find out that it's AVR HAL. But if I don't know the history and that microchip acquired Atmel, I think, or something like that, if I search for Arduino in board support crates, I will actually find one that says Arduino, and it will recommend the exact same thing. It will say AVR HAL. So great, I know I need AVR HAL because it says it's good for Arduino Uno, and the other boards are different. So I will click on it and I will start reading through documentation. If you go through this project by yourself, you'll need to do all these installs. I did this already. So realistically for me, I only need to follow this step. So it will say cargo install generate, and then I will need to generate a template. Let me do this. If you do it yourself again, like you have to run everything. So I do cargo generate, and I have a LED matrix. This is my project, so I'll call it display. But for now, this will be just Blinky. You can see you can select what chip you have, what board you have. So I have an Arduino Uno right now, and it's created. So I can CD into display. And let's see what got generated. What got generated is just a simple Blinky. So it blinks every 1 second. And realistically, if I do cargo run, it will take a little bit, but eventually you should see the LED blink. While this is compiling, actually it already finished, so I won't go through that. So you can see the LED blinking every 1 second. Great. To understand a bit more what's going on, you can see that in cargo toml, the specific Arduino HAL is used, like everything is pinned to specific versions. And the other interesting thing that you'll notice is there's a Rust toolchain toml, which fixes a nightly build from 2021. I actually tried to remove and use nightly or use latest, and AVR doesn't compile because some instruction not being available. So the workaround seems to be that older compiler version is used by default by this cargo generate. So, and the downside is if I go into cargo toml, it will say that edition is 2018. So if I try to do edition 2021, it will refuse to compile, which is slightly annoying. This also means that if you use crates, the crates should be minimum Rust version 2018 or before. Crates that are built for the latest 2021 will not work. And if you are interested of how things are flashed, there is .cargo config toml that explains how things are being built and what the target is. So you can see this is a target for Arduino Uno, and for all the other ones, like Arduino Mega and so on, there are other JSONs. So that's the quick overview. Basically, we have a Blinky, and we have some settings that use an older Rust version. If you get errors about Arduino edition, you have to use different packages, which is slightly annoying. So great. Now let's do something that's a bit more useful. So the first thing to do is Blinky is okay, but I tend to debug via the serial console. So I will go into the Arduino Uno examples, and then I will say, let me see how I print something to the screen. And it's reasonably simple. It puts a serial on a specific, some pins, and then I can use this uWriteLn. So let me copy and paste. I don't need all this information. So I created a serial, and the other thing that I will need, I will probably need to do this prelude and a read. Let's see if it compiles. It looks to compile. So cargo run. Unused import, but that's fine. And it says hello from Arduino. Great. I have a working example. So at this point, what I would like to do is I have a display matrix. So if you can see on the camera in the lower right, I have a display that is a 16 by 16 matrix. So if I look at it, it's let's say 16 by 16, and it is a WS 1282, I believe, which are called neopixels. So practically what this means, this is a display that can show any color on any of those pixels. Most often you can see them something like this. They are an LED strip, and the way you control them is you can control the first pixel, then the second, then the third, and so on. Just so happens that this LED panel is arrayed in a grid formation, so I can use it as, I guess, a very crude display, and that's my current plan. So first of all, I would like to figure out how I can control these. So I'll do cargo search 2812. Yeah, I have a typo. It says 2812. Sure. These are 2012. There are multiple drivers. The ones that are most useful, I would say, they are SPI drivers. I went into a previous video on how to use them. This one is very good, and this one is the one that I created mainly because Cortex M0 did not support this. But for our purposes, any of these will work. So I will go into cargo toml, and for the sake of an example, I will include both. You don't need to include both, obviously. You just pick one. But I just want to show how easy it is to switch between the two drivers. So I included these. If I look at the documentation right now, so I'll do cargo doc open. And let's see what shows up. Eventually, this takes a little bit. It has to compile, but after that, the browser should show a documentation for every one of these dependencies, and it goes recursively, like including other dependencies. So if I pick this one, SPI, it says it's for usage with smart LEDs, and it plans a specific trait. So for me, I will need to include in my cargo toml these traits as well. My graphics driver is weird, so ignore the fact that the display is messed up. Right, okay, so I have smart LEDs, and now I should be able to display LEDs. So the first attempt would be, let's create an SPI. So I need an SPI, and after that I will create a writer. And I don't know how to create an SPI, let's say, and I will go back to the examples, and I want to figure out how SPI is being set up. And if I'm looking at here, I have to include some things. Let's include them. I keep using include because of C++, but yeah, let's use them. And then it tells me about creating an SPI interface. I will go through it, and I create an SPI interface. Now, if I save, amazingly enough, I can see that pin 13 is used for SPI and LED. It's weird that the SPI uses an LED pin, but fine. So I cannot have an LED. So I don't have an LED, but I have to do something. I have SPI. So at this point, what I would like to do, I would like to create an LED driver. So let LEDs is one of these SPIs. I can pick either of them. New of my SPI. I don't think the SPI has to be mutable because I copy it inside. And the other thing that I will do, let's create 3 LEDs. So I know I have red, green, and blue, and I will use default values, which is black. And I want to have 3 LEDs, let's say. I will also want to set up specific values and change them after that. So I will say data, first element will be, I won't use 255 because it's too bright, so I'll use, let's say 33. So this will be red, this will be green, and this will be blue. And let's use LEDs and write. So LEDs, write, data. This should set it red, green, and blue. And now to have a little bit of interactivity, I have the indexing wrong here. Let's rotate data. What I expect is at this point, like if everything is set up correctly, write was not found because I need to implement the trait smart LEDs write, and I don't need the full duplex. LEDs is mutable, and I don't care about the result. I could use unwrap or anything else. So now everything is happy. The difference is I have to figure out how to connect things up. So I go into SPI new, and it tells me that the first pin that I give is the clock. So the LED is the clock, amazing. And then the one that I care about is a master out slave in. So basically the signal that goes out. And this is the second argument. So I have to put my control into D11. Let me do that real quick. All right, so I connected 5 volts and ground, and I put D11 into the output. So let's cargo run. It takes a bit. And you can see that it's reasonably bright actually on this camera. But yeah, LEDs are changing and it's usable. Also, to not make it this bright, maybe we can drop the power even more to the LEDs and see how that goes. Slightly better, I mean, for display purposes. So perfect, I have an LED matrix that works. Now I would like to find out how these LEDs are laid out. So I know I have a 16 by 16 matrix. So let's say this is my entire matrix. I'll make the first LED red, and then I will rotate right. And what I expect is that the LED will keep moving to the right, and then I will see how they are laid out, because I know when I control individual LEDs, I have to start with 0, 1, 2, and so on. Also, this delay is too long. I want things to move a bit faster, so let's say 50 milliseconds. Cargo run, and let's see how my display looks like. You can see going left to right, and then it goes like it S pattern. So that will be messy to find out the indexes. Most displays work with XY coordinates. So this means like I give it a row and a column, and this is not as easy to develop in this display, but we'll do it. So great. Now if I go into cargo dock, I could search. I know it's called embedded graphics, but generally if you look for embedded graphics, as we say, there is an embedded graphics crate, and this is what I want to do. So I want to build one of the world's slowest and smallest displays right now. So let me use embedded graphics and then look at the documentation. Oh, I also see now, I remember that I have both of these. So if you are interested in how easy it is to switch between the two drivers, I will go in here and I say instead of LEDs being this one, I will use a blocking SPI. And this is a totally different driver, but cargo run should probably do the exact same thing, hopefully. Let's see. Yep, it works. So anyway, if one crate doesn't work, use another. And the reason I'm showing this is, remember the limitation of using an older Rust compiler. So if some crates don't work, no problem, new crates, other different crates may work. Let's go back to embedded graphics. I added embedded graphics. And I opened the documentation. Embedded graphics is somewhat large, so it may take a bit, so it's fast enough. And let's look at embedded graphics. So embedded graphics is it's a library that you can display things. It even has specific simulators, so you don't need to develop on embedded if you have some specific needs. The downside of this is that it's reasonably big. So it will barely fit on an Arduino or another smaller items. So what it says is supports different kind of displays, and it doesn't include any drivers, but there is a draw target that if you implement, everything will work. And then there are specific displays that will make it work. With our display is not in here, so we'll write one. So let's go to the draw target, and read a bit of documentation. So what it says, a draw target is something that has dimensions, which makes sense. We have to tell it it's 16 by 16. And then we have to provide some way to draw pixels. So this thing will give us pixels, and I see it's an iterator that has pixels of a specific color. And then I don't need to provide fill contiguous. I guess it goes faster if I can provide a fast implementation of it. I don't need to provide fill solid because it has a default. I don't need to provide clear. Like each of these, if I provide them, code runs faster, but realistically I only need to draw pixels. And I need to implement dimensions. If I read through the documentation about dimensions, I'm wondering if it's somewhere here. Yep. Minimum implementation. Draw target is implemented on order 64 by 64. We'll do 16 by 16. And the other one says origin dimensions should be implemented. From documentation, depending on what functionality you use, implementing origin dimensions rather than dimensions is better. So if I look at origin dimensions, what it does, I have to implement a size that gives me what's the dimension starting from the top left corner. Let's go through it. I go to main, and what I would like to do is implement some sort of a class that is a draw target. So I have my LED display. And to do that, let's call it struct LED display. And this will write to some writer, which has to be a smart LED writer. And I know the color should be RGB8 because that's what my display supports. And here what I need to do is I have to have the writer itself. Great. And the other thing is what we said is I cannot write pixel by pixel. I have to write everything at once. So my plan is to cache everything into a memory block. So I'll call this frame buffer. And this is an RGB8. And the size is the size of my display. This wastes a bit of RAM, obviously. I think 256 times 3, so almost 1 kilobyte of RAM, but that should be fine. So I have my structure. Let's implement it. It will look kind of like this. So I'm implementing LED display, and the first thing I want to do, I want to be able to create a new one. Given a writer, and I will consume the writer, I have to return a new object. So this will be self. And the content is self with the same writer. And for frame buffer, I will use default. Default will be just black. And it's 16 by 16. Great, I have a creation of a new one. The other thing is I want to write this buffer. So I want to have some sort of a flush. So I will say flush. Self is mutable. And let's say self write. Realistically, I have to do this. Except instead of LEDs, I'll do self. And instead of data, it will be self frame buffer. Great. So I have a flush. Let's use this new class. So I have a new display of LEDs. I will not delay. I will delay a bit longer, and this should do nothing because obviously my data is completely empty. So now the implementation that I need is implement that display origin, like I have to say origin dimensions. I will copy and paste this one because it's faster to write. So what I will say, I'm implementing origin dimensions for LED display. The only thing that origin dimensions requires is a function named size that returns a size. And I know I'm at 16 by 16 thing, so let me display it. Then the next part is I need to implement a draw target, which is a bit more involved. So let's go through it. The first thing I will look at the draw target. Let's move a little bit back. Draw target needs a pixel color and it needs some sort of an error. I don't really care about errors here, which is bad. Realistically, in a production thing, I will implement error. But for now, let's say I have an error, and if somebody wants to write a pixel out of bounds, I will return out of bounds. So that's my only error. So let's go type color, first of all, equals, and it has to be a color that the embedded graphics knows about, I think. So I'll use RGB 888. And now I have to make the includes happy. I'll accept lots of replacements. Okay. And I'm missing more. I know about it. Type error is draw error, which I defined above. And now I have to implement a draw iterator of some I. Which returns a result. No real result, I just use the error. And I have to return a draw error because that's my error type. And I need to put some constraints onto I based on the documentation. I should be something that can be transformed into an iterator that gives me pixel values. And I return success here. It doesn't know what pixel is, that's fine. I can accept the replacement. And I don't use data yet. So let's implement it. I know that data can be converted into an iterator, so I can use a for loop. So if I say for pixel, pixel happens to be a point and a color. If I look at the documentation, so I know this exists and works. What I will need to say let index be something. I don't know yet what the index is because the point will be XY coordinates. I have to put it as a array index, and then I will say self frame buffer of this index, and it is the red, green, and blue. So it will be color red, green, blue, and conversion. So let's see if this compiles. No method named, but once I include it, it should be fine. So I don't use point. I know I don't use point. So let's call that this some sort of self point x point y. So what I'm saying is if I have a point, I can get the index assuming that this point is from the corner upper left and upper y, and I don't think I need to split it up. That's weird. So I will need a function that is called index top left, and I will take self, and I need to take a point. Is of type point. It says unknown. Great. Let's see what a pixel is. Graphics core pixel has a point. So it's in geometry point. It's a struct point. So for now, I'm saying 0. Let's see if this compiles. Oh, wrong return type. Use size because it's an array index. I'm not using point, but that's fine. So first of all, this is the first part that I can check for out of bounds. So let's say this is a result. That could be a usize or it could be error. I called it draw error. And for now, I will return OK of 0. And going back here, index top left may return an error, so question mark. Everything compiles, but it tells me I don't use point. So let's use point. I claim that I'm doing bounce checking. So let's do that. So if The value should be between 0 and 15. So if this range does not contain point x, or the same range does not contain point of y, we are out of bounds. Great. So now let's find the index. Mismatched pipe. Oh, okay. It tells me that reference is better. I can do that. First of all, I don't want to deal with negative numbers, and I know they are between 0 and 5. So let's say let x equals point as u size, and the same with y. And now let's figure out how the pixel is laid out. So I will say layout. Autocomplete is strange. Layout is the indexes are bottom to top, and I will say that odd rows go left to right, even rows go right to left. So how do I find the index? So let's say let index is, first of all, it's bottom to top. So this means when I get an index from the top, my actual row is 15 minus y. So I'm inverting the direction of y, which makes sense. And this is times 16. So this will give me the y coordinate. And then the other one is I need to consider odd and even rows differently. So I will say if y mod 2 equals 1, what do I do then? Otherwise, something else. And I'll return index. And thinking about it, and this is also through some trial and error, it's easy to flip them. If the row is even, this means I go left to right because the row will actually go from top to bottom. So this condition that says odd and even is actually flipped. So right now, if I say if it's odd, then I keep going correctly, and otherwise I invert. And we'll see if this actually works. But for now, this is what I believe is okay. It's horrible, but I have an index from top left. And let's try it out. LEDs that do not need to be mutable. Display has to be mutable because I flush. And now I would like display something. If I use display, I can look at the examples from embedded graphics. So if I go back and forth a little bit here, at some point there will be examples. This is one of the examples. One word of caution would be it can display text, and I managed to make it display text on Cortex M0, so on STM32. Arduino will boot loop when you display graphics, so that's annoying, but we can display rectangles and stuff. Let's do that. So when you display, first of all, you have some sort of a style. So I will create a style on top, and I will say, let's say this is a circle style, or want to do something. These are too bright, 33, so we said 10 is better, maybe even 5. So I will say I create a circle, and I want to fill it. I want to have an outline. So the filling will be some color, I don't know what this is, and outline will be red, and of size 1 pixel. And then I want to display this circle, and I will display it in a loop for now, which is reasonably silly, but let's put it like this. And it needs a circle X and Y. My display is 16 by 16, so 8.4 is somewhere. And now I have to implement to add usages for all of this, maybe even more. It doesn't know what stroke alignment is. I think it should be in primitives with the rest, so let's do this. And it does a method not found into styled. I need to add primitive. Autocomplete is reasonably simple. Well, I'll need to pause the video and see what this complains about. It should work. Okay, coming back after actually reading what the compiler is telling me, it says I just need to include drawable target. Fine. I have a drawable trait, and I should be able to display a circle. So let's, not cargo doc open, that's useless. Let's do cargo run. And what I expect is to have some sort of a circle somewhere. But because this plate is quite big, I cannot fit into RAM anymore. Not RAM, sorry, text. So Flash is too small. So I have to compile the release. So I don't have any debug information and everything is optimized for size. This will be slightly slower to compile, but at least it will run. So this is when you work with small MCUs, at some point you run out of Flash. And you can see it's an interesting circle. Let's do something useful with it. Well, useful is questionable, but what I would like to do is I want to make it bounce left and right on the screen. And to do this, I'll pick that I want to have a position for X. Let's say circle X equals 1. And the other thing that I'd like to move it left and right. There's a bit C++, generally you should call it actually left and right with structures, but this will be good enough. So if circle X is smaller than 1, then I want to start moving it towards the right. Else, if it's too big, let's say greater than or equal than 10, then I would like to move it towards the left. And let's do the actual move. And I will draw it. Notice that I don't actually clear the display, which is bad. So this will create a very weird streak, I guess, on the display. We'll fix it by using clear. Let's see what it does. Oh, it does the weird stuff, but very, very slowly. So first of all, this is too small of an FPS. And the other thing is I need to clear the display, I guess, with black before actually drawing. Great. Let's see what happens. I have an animated circle, which is neat. Also, I can see how much FPS can I build. So if I remove every single delay, it will go slightly fast. Oh yeah, that's reasonably fast. Nothing really, it's not 60 FPS, but at least it's a little bit of display. So that was it. This is how you bring up Arduino. I showed you how to make it link. I showed you how to write to the serial console and actually have a practical project, which means LED lights. There might be pains because the device is too small, and if you try to, for example, write text in here, it will boot loop, and I wasn't able to fix that. But for simple projects, these things work. I hope this is interesting or useful or both. Have a great day. Thank you.